story two of my pupils told me the other day about a factory they passed on their way home from Sunday school. This factory is in Wolverhampton, the centre of England, known as the Black Country. A coal seam extends from the north and finishes at Wolverhampton, so the town itself is industrial to the north and agricultural to the south and west. Found no one there, and the doors locked, as they expected on a Sunday afternoon. You can imagine their surprise when an old man appeared. He explained that Tractor Spares Limited produce idlers, sprockets, lower rollers, and track assemblers. Now, I would like you to meet some personalities. First, Mr. Ray Chapman, photographer and secretary. Then Mr. Dando, scriptwriter and works director. Mr. Arthur Blount, commentator and auditor. Mr. Jones, music and export director. Mr. Charles Waite, managing director and director of this film. The old man offered to show the boys around. Imagine their surprise when they found everyone at work. He went on to explain that this turret lathe prepares the two large separate rims ready for welding, while the fire lathe handles the smaller size rollers. After welding, various operations follow each other on these Herbert No. 9 turret lathes, such as machining one rim and facing the end of the bore. Then facing the other bore end and machining the second rim and final boring. Drilling and tapping is carried out on the 6-spindle Archdale machine. Now this is the most important part of the whole process. Instead of producing these rollers from expensive alloy steels, we use a 0.4 to 0.5 carbon steel and high-frequency harden to any given depth. This roller will have a 3/8 of an inch hardened case on it, which will give a hardness of Rockwell C60, far superior to all those other fancy steels which our competitors are compelled to use through lack of this plant. This workstation was designed and built by the staff of Tractor Spares Limited. Finally, each roller is honed to 1/2 of an inch in the bore. This 200-ton hydraulic press then assembles the finished rollers with shaft bushings and all the other bits and pieces required in a completed roller assembly. On the other hand, the customer may require his rollers reconditioning, in which case the old roller assembly is dismantled. All the bits and pieces are then degreased. Thorough inspection is made of all the worn parts. The roller itself is then mounted on this rotary manipulator, and welding wire, together with flux, is continuously fed onto the worn section of the rim. This method is known as the submerged arc welding process. Its advantages over hand welding are numerous. The layer of weld is as thick as 600 amps are being used. Furthermore, this layer of weld is laid on very evenly. After the tread and bore have been machined, all the spares are assembled into the reconditioned roller. As the old man said, you can see that Tractor Spares Limited are in a very happy position to be able to offer the customer either new or reconditioned rollers. Let's return to the old 2-ton Caterpillar tractor. This was Caterpillar's first production in 1925 and of course has a petrol engine. It is not until 1931 that a diesel engine tractor was produced. The basic principle of the present-day machine is based on this old 2-tonner. Other items which are also subjected to excessive wear and tear are the front idlers and the driving sprockets. Both of these items are quite heavy and not easy to handle unless lifting gear is available. This Heister crane makes light work of handling these into the machine shop. Let's take the sprocket first. These are machined on 2 vertical boring machines. The far machine handles operation 1 of facing the inside and taper turning the bore. One operator can handle the 2 machines and number 2 vertical bore is seen facing the other side. This drilling machine drills all the guard rivet holes. Afterwards, the splining is carried out on this slot. Finally, this Denver electronically controlled flame hardener hardens the teeth. After loading and setting up the sprocket, the operator merely presses the button, which automatically heats the metal to the correct temperature, shuts off the flame, and quenches out with water. The whole operation is recorded on a graph. May, of course, require his sprockets reconditioning, in which case the old rims are burnt off. The new rim is set in position on 3 jacks, and the pointer determines the accuracy with which the rim has been fitted. It is then necessary to position the rim correctly with the hub by measuring the distance from the rim edge to the hub face. The rim is then tack welded to the spokes. While spinning, the whole sprocket determines if any wobble is imminent. The rim is then welded, one run of weld at a time in a given rotation of spokes. In the case of sprockets having inexpensive hubs, then the method is different, in that each tooth is welded separately. Then rough ground on this heavy hand grinder, and finish ground on these high cycle grinders. New idlers are produced in much the same manner as the sprockets. Two plates are welded on either side of the idler. Operation 1 and 2 follow each other on these two vertical boring machines. Are drilled and tapped. The flame hardener is then set up to accept each idler. The flame jets and quenches are raised into predetermined position and heat is applied. The intensity of the heat controls the speed at which the idler rotates. Should the customer require his idler's reconditioning, then the weld is applied by this submerged arc welding machine, after which the idler is ready for a new lease of life. The main product of Trac Spares Limited is complete tracks, and they are the only firm in the UK producing complete track assemblies. These assemblies consist of four main items: grouser plates, links, pins and bushings. Firstly, the grouser plates. These long sections are rolled into their correct shape at the steel mills and are sent to us in 300-ton lots. Two sections are placed face to face and taken into the factory for processing. This cold saw hydraulically clamps the sections in two directions, while the saw cuts through the two plates every 70 seconds. Oxyacetylene profile cut to allow the link clearance when rolling round the sprockets and idlers. Drilling of the 6 holes is carried out on this machine, which is tooled up to undertake this in one operation. Heat treatment and painting complete these grasses. Trac links forgings, after normalizing, thus improving the mechanical properties, are 100% inspected. Left and right hand links are clamped alternatively onto a revolving drum. Each link in turn passes between two revolving cutters, which mill both top and bottom faces in one operation. The operator just has time to remove a finished link and replace it with a new link, still in its forged condition. Again, high-frequency hardening on this machine gives the links the deep hardened case as demanded by the genuine tractor manufacturers. The links are fed continuously down a moving belt, which passes under a specially constructed inductor. As soon as the link reaches the critical heat transformation range, when the ferrite dissolves into the austenite, when the solution is complete, it is known as perlite. This is immediately quenched by a cold water spray, which changes its composition, giving a deep hardened zone. Stress relieving follows in the electric furnace. In pairs are clamped into these platens. The machine roughly bores out the pin and bush holes, also the bush counterbore. At the same time, opposed drilling heads drill the bolt holes. The machine then finally finishes both the pin and bush holes to very fine limits. This operation completes the link, except for crack detecting, which is automatically carried out by magnetizing each link and at the same time drenching it with magnetic ink. The girl inspector views each link under this infra-black lamp. Any cracks show up bright purple. Now let us look at the production of pin and bush groups. Bar and tubing is selected from stock. This crane handles the material onto these machine carriers. These Brooks machines part off the material to a given length automatically, either bar steel for the pins or tubing for the bushings. The pins then go to this high-frequency pin hardening station. This platform raises the pins up to the operator for easy handling. Each pin, one by one, is fed through this inductor, and up to 800 pins per hour receive this treatment. The core of the pin is unchanged, and cases up to 0.200 are easily applied. The principle of heating is that small eddy currents are induced into the surface of the steel, and these produce rapid heating up caused by the violent fluctuations of the very minute particles of steel acting as magnets under the constantly oscillating high-frequency power. Centerless grinding to standard or oversize completes the work on the pins. The tubing, after parting off to length, then has to be bored out to ensure that the hole is eccentric with the outside. 6 bushings at a time are being bored on this 6-spindle Conomatic borer. number 4 turret lathe chamfers the ends, at the same time machines the internal taper at each end of the bush. The bush is fitted on a mandrel, and this small piece lathe turns down both ends of the bush in one operation. At the same time, the 2 rear tools radius both ends. Only 150 kilowatt motor-generating high-frequency bush station in the world, undertaking internal and external hardening of Trac bushings. The bushings are hopper-fed down to this magnetic arm. It then places one at a time into this station, which hardens the external only. On completion of the cycle, another magnetic arm collects the bush and places it in the next station, which hardens the internal bore. Bush is then hardened inside and outside to predetermined depths which never vary once the machine is set. A third magnetic arm removes the bush from station 2 and drops it into the discharge chute. Grinding completes the bushing similar to the standards of the pin. Pins, bushings, cracklings, grouses, etc. are then assembled at one of our many Trac presses for assembly into Trac assemblies. While you are here, you may be interested in the reconditioning of Tracs. Here are 2 more presses. Their sole occupation is the dismantling of customers' old Tracs for reconditioning. The old dirty links are then loaded into this wheelabrator shot blasting machine, and after 10 minutes of treatment, they are unloaded all nice and clean. This enables a better painting finish and a more accurate and 10 times faster inspection. These girls inspect each link for cracks, elongated bolt holes, and oversized pin and bush holes. The customer then receives a report on his Tracs and a quotation. Work is withheld pending the customer's reply and instructions. Welders are kept constantly busy on this work, applying weld by hand. Each welder stamps the links he has been handling. The links in batches are then bolted together and the wear face is ground on these 2 surface grinding machines. high-speed grinders completes the reconditioned link. Here you see the finished link being tried for size in the gauge. Here we have 3 more hydraulic presses assembling the chains. After the reconditioned links have been assembled into complete tracks, they are coiled up on this turntable. The final operation of painting is carried out in this water-back paint spray booth. As a sideline, a large number of men are employed manufacturing cabs for all types of wheeled and crawler tractors. The tour of the plant was over, and the time had come for the old man to say goodbye. He explained that the old crate, as they called it, was his car, which he made in 1909. It is called the Little Britain. They made over 1,000 vehicles before they changed over to producing tractor spares and called the company by that name. Then, surprise followed surprise. The old man disappears. The cinema. Lo and behold, the tractor. Was it all a dream? No. Tractor Spares Limited were the first firm in the world to produce Wildcat spares. And let us all remember the old man's motto, keep on the right track with Tractor Spares Limited.